Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by DigitalOcean, the simplest cloud platform out there. And we're excited to share they now offer dedicated virtual droplets. And unlike standard droplets, which use shared virtual CPU threads, their two performance plans, general purpose and CPU optimized, they have dedicated virtual CPU threads. This translates to higher performance and increased consistency during CPU intensive processes. So if you have build boxes, CI/CD, video encoding, machine learning, ad serving, game servers, databases, batch processing, data mining, application servers, or active front-end web servers that need to be full duty CPU all day, every day, then check out DigitalOcean's dedicated virtual CPU droplets. Pricing is very competitive, starting at $40 a month. Learn more and get started for free with a $100 credit at do.co/changelog. Again, do.co/changelog. Welcome to Practical AI, a weekly podcast about making artificial intelligence practical, productive, and accessible to everyone. This is where conversations around AI, machine learning, and data science happen. Join the community and Slack with us around various topics of the show at changelog.com/community. Follow us on Twitter. We're at Practical AI FM. And now onto the show.
Welcome to Practical AI. This is Daniel Whitenack. I am a data scientist with SIL International, and I'm here with my co-host, Chris Benson, who's a chief AI strategist at Lockheed Martin. How you doing, Chris?
Doing great, Daniel. How's it going today?
It's going great. You know, finally got a break in the heat wave that's been all over the U.S. here. I know you're a little bit further south than me, but yeah. I stepped out yesterday and I almost thought I needed a jacket because the difference in temperature was so drastic.
Oh, I haven't gotten the benefit of the cold weather down here. I'm in Atlanta, and so it's still quite toasty and humid here. Last week I was up in Boston the whole week, and I was really counting on nice, cool Boston weather, and it just didn't happen. It was only about 5 degrees, cooler up there than it was down here. So it was sad. Yeah. Well, I have a bit of story. So when I first joined, or my first job as a data scientist was with this startup, and at the time everybody was into microservices and all of this stuff, and we started talking about microservices. I learned what those were, but they kept saying things like Redis this and Redis that, and we're going to use Redis for this and Redis for that. And eventually I learned that Redis is this cool data thing that can be used for like message passing and data caching and data store and all this stuff. And recently I saw that Redis released this project called RedisAI. So that's going to be the topic of today's conversation. We're joined by Pieter Cailliau, who is a senior product manager at Redis Labs. Welcome, Pieter.
Hi, guys.
Yeah. So, Pieter, could you just give us a little bit of a background about how you got into software and how you ended up at Redis?
Oh, that's it's quite a long story, but I'll try to keep it short. So effectively, I was when I was as a kid, I was into astronomy, and I wanted to always kind of like motorize my telescope so it could effectively follow the turning of the sky, so to have long exposure of photos.
Right. And that sounds awesome.
That brought me into electromechanical engineering, and then afterwards computer science. My first job was at TomTom. Sometimes in the US they say TomTom, so it depends a bit, but I was working on the portable navigation devices, right? I was working on the map backend in Belgium, in Ghent. Map quality assurance is a difficult problem, right? So TomTom tries to differentiate in how well the quality of these maps, and they have many rules. And one of those rules is a very expensive rule. It's is the map still connected, right? Can you still travel from everywhere to everywhere? You could imagine, for example, you have a continent, you have an island, there's a bridge in between. And the map editor says this bridge is now one-way traffic. So in the morning you go to the island, in the evening you want to go back, but your device says, no, sorry, can't do.
That would be a problem.
That would be a problem. So for that, effectively, we were using a graph database. We were effectively using Neo4j. And that I rolled into the NoSQL database world because I joined Neo4j, worked there for three and a half years. And afterwards, I joined Redis, first as a solutions architect. And then afterwards, they said, like, hey, we've got one of these modules here is graph related. And I joined effectively the product management team to initially first support the Redis graph module. But now I have 7 of these modules under my, we'll call it supervision or umbrella.
Oh, wow. That's great. Yeah. How many in total, what is the ecosystem of modules around Redis? I imagine there's quite a few.
There is quite a few, right? So I don't know exactly, but I think we have 25 open source modules. Maybe it's a bit good for the audience that I introduce what these modules are and effectively introduce what Redis is, because that will make the story nicer.
Yeah, that's no problem.
So Redis is a key value store. It's an in-memory database. It's a NoSQL database. The most typical in-memory database that most people know is Memcache, and in Memcache, the value is always a string. In Redis, however, you can have different data types. It can be either a string, but it can also be a numeric value, a list, a sorted set, a hash, etc. So you have many data types. You can effectively see it as memory as a service. So if you're coding, you could say, okay, I have this data structure that is residing within a distributed database.
So could you just give an idea? So you've kind of called out Redis as this key value store and a NoSQL database. And you also mentioned like graph databases. Could you just kind of generally describe, how the NoSQL databases are separate from what people might have in mind that they execute like select statements on?
Sometimes confusing, right? So NoSQL stands for not only SQL. So it was the movement that, well, we're living in some buzzwords, right? So there is big data, there is much more data.
Yeah, we have a podcast about AI, so we totally get the buzzwords.
Nothing but buzzwords.
Nothing but yeah. So databases had to consume or to ingest high volumes of data, and there were some performance issues. So it's not the entire picture, but what people kind of like did was they create some databases and they threw away everything that was kind of like reducing the performance or slowing down the performance of your database. So NoSQL databases typically have they also have a different paradigm, but they also have like less strict authentication. They're quite frequently they're schema-less, so you can put lots of heterogeneous data inside it. And in that NoSQL section of database, you have quite a lot of database models, right? There's a key value store, but there's also graph. You could see search also as a database model. There's a time series, which is effectively ramping up lately, which is another database model, for which we also, by the way, have a very interesting module. But yeah, I don't know if you want me to explain further or talk more about NoSQL databases or how they came to life.
That was really helpful for me. I know that like if we kind of zero down in on the key value stores, so you mentioned like one distinguishing feature of Redis is that like the values don't have to just be strings. So you gave some other examples of things that they could be. I forget what those were.
For example, there's a list. So it's it's a list data type, right? So you can effectively, it's interesting. Sometimes when I give a talk, I ask people. So for example, let's do the exercise, right? So you have 2 sets of items. And inside Redis, they will reside as a set. So for example, imagine you have 2 products and they have a set of tags. Now, what could you do with these 2 sets? Which questions could you ask the database with 2 sets? Maybe I should hint.
So overlapping entries or something like that?
Yeah. Correct. So you could do an intersection, you could do a union. So this is kind of like what Redis is, right? So your data structure, effectively, all the methods you could do in your programming language, they kind of like have commands that you could execute against Redis.
Okay, so you could have like a bunch of values as lists and execute some command or in some Redis client or something to get the intersection of those values.
Correct. So in a list, you could get the first element, you could get the last element, you could query a range or get the exact element. You could also pop an element, but in a set, you could ask, for example, well, is this in a very, very efficient way? Does this element belong in, or is present in your set, etc.?
So I was going to ask, could you kind of like, what are some of the most typical ways that Redis users are using Redis? What's a couple of really common use cases that people are most likely to do?
Well, it's very broad, right? It's a general purpose database. So you could use it for anything. But the most common thing, or that people are using Redis for currently, is for session caching. So your shopping baskets, etc. So everything that you keep track of in sessions, also for caching. But there are also many things you could use as a queue, right? So there's next to originally there was the list data type where you could effectively distribute messages with, blocking on these on this list on retrieving the first element or the last element. But nowadays we also have a streams data type, which is we'll call it Kafkaesque, right? So it has similar capabilities. You can have you can use it as a stream or as a topic. So sorry, as a topic or as a queue. So in a queue, you can have, for example, a consumer group, and each message will only be consumed by a single consumer. But if you use it as a stream, you could, for example, say, I want to start reading the stream from here, or I just want to catch up from the end of the stream, etc. So also for that, with that specific data type, you could effectively do a message broker or event sourcing use cases.
Gotcha. Okay.
But there are many more. People use it sometimes to do distributed locking.
Yeah. So you've kind of also alluded to the fact that, like, at least some of these modules of Redis are open source. Like Redis as a company, I know that like there's some things that are like open or open-ish. Like, how does the company operate? And like Redis itself, like, can you find it on GitHub? And what's kind of the model around Redis?
That's a good question, right? So Redis itself is entirely open source, so it's a BSD license. So you can take it, you can fork it, you can resell it, you can do whatever you want with it. Then there is a piece where we have these modules. These modules have a Redis source available license. So the idea is that you can effectively do anything with these modules, apart from creating a database as a service with these modules.
Gotcha.
So you can embed it inside your product. And effectively, it's a bit of a strategic way to compete to cloud providers, just simply taking all the open source products and then effectively offering them as a service. The last part is our Redis Enterprise part, which is a closed source part. It doesn't have any data or engineering specific capabilities. However, it has lots of enterprise features that your company might be interested in or is most likely interested in. So there's easy to scale your database. There's effectively it's an entire database management system. The way I sometimes position it is that, do you want to become an expert in building your application, or do you want to become an expert in deploying Redis, right? So if you
that makes sense.
If you don't want to do the second one, then we've got an enterprise solution for that.
So could you guys give us some examples of some of the modules that you have available? I'm curious about what the scope of those are.
Well, the story effectively is, so we have all these data types, and the original core contributor or creator of Redis, Salvatore Sanfilippo, he was receiving lots of requests and said like, oh, you don't have this data type. How about this data type? So he created an API, so you could effectively create your own modules and your own data structures and your own commands against those data structures. So the commands were, for example, do the intersection in between two sets, and the sets was effectively the data structure. And in that way, you effectively could say like, well, I'm receiving lots of requests. Now you can build your own data structures, and by creating those, you effectively inherit all the goodies from the mothership, right? So Redis has many things inside. So it has memory management, but it also allows you to cluster your database. And one of the misconceptions that many people have, by the way, is that Redis is purely a cache. It's effectively a database. However, data lives in memory first, and then we have tunable durability. So now if you implement your data structure inside a module, you can also benefit from that durability and also have an entire spectrum of client libraries that can effectively connect to your database and reach out to those data structures in those modules. Now, to answer your question, right? So there are quite a lot of them, but the ones that we effectively think that we're effectively contributing the most to, there are 7 of those. So the most mature one is most likely going to be Redis Search. So it's an inverted index. It's kind of like Apache Lucene. And Apache Lucene, for those who don't know, Apache Lucene is effectively the core building blocks of Elasticsearch and Solr technologies. So, but we've built our own inverted index. It's written in C. We serve the entire data or the index from within memory, and also the index is instantly reflected. So we do have some advantages there. We don't have feature parity, of course, to these products that have been around for decades, I think. However, we get a very, very high performance in that search. Then there is Redis Graph, which adds graph capabilities. I know all these modules, right? So I can talk for hours about them. So, but Redis Graph itself is a very interesting technology. So I always try to differentiate graph native technologies and graph technologies. So you can put a graph API on top of a relational database. However, it will be quite slow, right? You make one table which is nodes, another table which is relationships. But when you have to do a traversal or search, for example, a Dijkstra algorithm, which is a search algorithm between 2 nodes, you will have to do a join in between those tables continuously. So a graph native database.
I'm so glad you're calling this out, because I actually got burned by this very issue on a project where we were trying to implement a graph database, and I mistakenly chose a graph layer on top of MongoDB, which is another database, and it was so slow. And basically the graph logic was really interesting and good for the project, but we got burned because of this issue that you're talking about. So thanks for explaining that.
Yeah. So the difference is that you have graph native, you have an O1 time complexity to go from one node to another node, right? So instead of an O log n in a relational database, and typically you do try to keep the data as close as possible, residing within the same key effectively in Redis. Okay. And we've got Redis Bloom, which is a set of probabilistic data structures like a Bloom filter, a Cocoa filter. We also added top K. We've got Redis JSON, which is going to take your JSON document and is going to split it up inside a tree, so that in an atomic operation, you can, in a large JSON document, you could, for example, append some data to an array, or you could increment a numeric value inside your JSON document without having to fetch it and putting it back. Then there's Redis Time Series, which is the last one that went GA, which effectively adds time series capabilities to Redis. It allows you to do, for example, in the role of IoT, it's very interesting that you've got lots of raw data, but you also would like to downsample it. You could do that inside Redis already, right? There are many ways to do that. However, you had to write lots of client-side code, and Redis Time Series comes with a toolbox to do aggregations over lots of samples, or to downsample them, so you don't keep all your raw data the further you go into history. One more interesting module before we dig into potentially into RedisAI is Redis Gears, and it's interesting to mention because Redis Gears will be kind of like the serverless of Redis. So you can do 2 things. You can do like MapReduce type of operations on top of your entire data set. Mm-hmm. Because Redis allows you to, it's a key value store, so you can shard it, you can partition it. So if you want to run a query across all these shards, there was no clean solution for that. So Redis Gears will give that to you. The second part is that it can also execute certain scripts based upon certain triggers or certain events. So it could be, for example, you add something to a stream, or you change a certain key, but it could also be time-based, and then you execute certain codes. And this kind of makes the entire multi-model story very beautiful. I know in our company, I'm the first one to say, if somebody says, "Hey, multi-module, multi-model," please be cautious about that. So it's not because we have multiple modules in a database that we're a multi-model database, but Redis Gears kind of allows you to do that. So you have, for example, a stream of data. You get some name change, for example. You could say, hey, the script is going to react upon that new piece of data. It's going to say, hey, Redis search, please update the name of this person. But also, hey, Redis graph, make sure that graph person or the graph node is updated. So it can effectively talk to all these modules. And then it becomes very, very interesting.
So you just mentioned kind of this idea of multi-modules or multi-module and like the ability to run scripts, the ability to put things together. You also mentioned Redis AI, which is really what we want to get into in the rest of this discussion. But I was wondering, just kind of in terms of background, what is the background on Redis AI in terms of why the team was motivated to create it? Was it something that users were asking for? They're like, oh, we love Redis, but we want to integrate this somehow with like AI models, or like what's the backstory on that, and kind of how did it come about?
It came effectively from three ways, right? So the first one is that Salvatore, as when he created this module API, the first module he created was neural Redis. So that was the first kind of like indication that it could be potentially a need for that. Then there was also some engineers inside Redis Labs who created a module called RedisML. So they thought that they could, for example, have very specific data structures, for example, for a random forest tree, for some regression, some specific data structures for these models or these AI models, and effectively host them inside Redis. And then there was also somebody who was creating RedisDL, another module which is then focused on deep learning. And we kind of like combined these efforts, and we created one module which is called RedisAI. Now, that's how it came to life, right? And but the need, or explaining the need, is also quite important. So there are two things we believe there, right? So there is data locality, and then there's effectively the DevOps part of publishing your model. The publishing of your model, it's not always straightforward. It's not always convenient. So you can, for example, have your model, you wrap it inside a Flask application, but then you have to scale it yourself. You have to add all these things manually. But with Redis, we effectively have all these things already. We can scale it. We can cluster your database. So we have all these clients already. They can connect to it. We already have high availability. We have effectively also durability. So if your data, if your Flask application goes down and you didn't, for example, if there's no high availability, then your model serving would no longer be available. So all the goodies that Redis brings as a database, you suddenly also get for free if you would add Redis AI to or these models to Redis. The second part is that we believe is the data locality. For that, maybe it's interesting to give a model or to tell a story. For example, you have a chatbot application, and this chatbot application has a certain model, so it takes in two tensors, or it takes in two input parameters. The first one is your latest message that the chatbot received, but also the second one is the intermediate state. So there's an intermediate state of the past or the history of that conversation. And combined with that, it produces an output, and the output is the response, but it's also a new intermediate state. That is a new history of your conversation. Now, you want to keep that as close as possible to that model. You don't want to go and fetch it from another database, then bring it to your application or to your own Flask wrapper where you've written, where you try to deploy your model. It adds another data fetching. For sure, if that data you want to fetch becomes large, there will be some latency. And well, what we believe in Redis is that everything should be extremely fast, right? Because there's a high throughput. Well, there's a demand for high throughput databases or high throughput requests with very low latency. Everything needs to be more and more snappy. By actually creating these data structures or by creating Redis AI, we could now run your inference where your data lives, right? Because people sometimes also have, for example, some extra input data, get a user profile and feed it to your model to do a better inference or classification, right? So that now that data doesn't need to be fetched from another host or from another database. It's already there. It can live within Redis next to the model.
So, as you talk about the chatbot example, where is the tensor serving where you're executing deep learning models? How does that fit into this? Could you kind of give it to us, give the context of that so that we can kind of map it together?
There are three data structures inside Redis AI that we add. So there's a tensor, there's a script, and there's a model. So you can effectively now, the key value store, the value now can be a tensor. So you can host your tensors inside Redis. Is that answering your question?
I think so. I was just wanting to kind of like break it down in the sense of with the chatbot kind of walking through how you're using the module, how RedisAI is fitting into that example. If you were coming into it for the first time as a user that was wanting to use this, just kind of taking that as a contextual example about how I might do that. Like if I sit down after our conversation and try to do it, can you just kind of describe it end to end in terms of how that happens?
Right. So your training part is still going to be the same, right? So, but once you've trained your model and you're sure that it's the right fit for it, you can effectively import it inside Redis AI. So we're building quite some tooling around it to make it more easy, so that you can do it, for example, directly from scikit-learn. There's already a connector for that. We also have a connector, for example, from Spark. So you take your model and you can put it inside Redis. The next thing is, if you want to build an application, you will have some client library that is going to connect to Redis. And from that client library, you could post effectively your tensor inside Redis. You could say, hey, here's my new message. There's also the output tensor. Well, there's also the input tensor of the intermediate state. And then you can effectively run that model. It's another command that you can run from the client side or the client library application side to do your inference.
Yeah, I'm gonna kind of so I have a theory going in my mind, and I want to kind of check it. So you mentioned the three data structures. You got the tensor, the graph, or the model, and then the script. So would it be true that you could kind of have tensors stored in Redis, and these might be like test examples, or maybe these are like knowledge base articles if you're answering questions out of a knowledge base, or maybe it's like some images or something, and you could execute like certain of the script database or data structures on those tensors to maybe do like pre-processing or something, and like combine them in interesting ways before they would be passed off to maybe the graph data structure to actually perform an inference with a model. And then maybe it would go back to the scripts for like post-processing, and then the result stored in like tensor data structure again. Is that kind of on the right track, or?
That is exactly it. That's how we want it to be. So you can have these three data structures, and you can combine them and mix and match them as you go. So you can also use that as if you would like to run several models and combine the results, you could also use a script and run them several graphs underneath. One more thing is that, that is coming up is effectively you will have a command which is a direct acyclic graph, so you can effectively execute those commands combined, right? So you could, for example, you set a tensor, but then the output is passed to a script. The script's output is then passed to a model, and then the model output is once again passed to a script, and then the output of that script could be a tensor that is persisted inside Redis, right? So you can kind of like pipeline those commands in a single call towards Redis. But your explanation was spot on.
Awesome. Yeah. So I'm just part of the reason why I have that. Excuse me. I have that in mind is like I have a direct use case I'm thinking of in the problems I'm solving now. So we have like a bunch of knowledge base articles that we're doing reading comprehension on. But we're also doing like a full text search of those based on TF-IDF. And so my thought is, what if I could, so I don't know, check me on this to see if this would be a proper way to use RedisAI, but I could like store the knowledge base article text as certain maybe string elements, string data structures in Redis. And then I could use maybe a script in combination with the graph that would store like my vectorizer, my TF-IDF vectorizer, to transform those into like actual tensors in the tensor data structure. And then when I would do like a document search on those, maybe I could use some of the like overlapping or score generation script or something to actually do the matching. I don't know. What do you think?
I think that makes perfect sense to me. That this is effectively what we want to do, and it can even be more beautiful. You mentioned, for example, you would fetch your knowledge graph as a tensor. If your knowledge graph is changing over time, right, you could effectively host that knowledge graph inside the Redis graph. So then it's there, it's living as a database. You can effectively let it evolve over time. It might be, for example, that you want to add scoring, or you could say, well, on given searches, you want to bumper certain nodes or certain relevancies. Or you might want to make custom queries. You want use as an input for your graph, right? If you want to say, well, if you want to make something very tailor-made, and then effectively gears could effectively also be gluing all of these things together, right? So your script could already, not at this moment in time, but it's something we plan to do. Your script could effectively then consult Redis graph and fetch that data for you.
Okay, yeah. So there could be like, there could be routing logic that routes between all of these different scripts and the graphs, and the scripts could call the graph, so the scripts could get data from the tensors and all of that. Is that right?
Yes, correct. It's a bit confusing here because we're saying graph. We can say, well, that's why we renamed it to model inside Redis and Redis AI.
Okay.
Because we already have Redis graph. That's why we.
Yeah, no, that makes sense. I'm looking at one of these figures from the RedisAI docs, and there's a graph blob section. So that makes sense. That would help with the confusing terminology, which is, I guess, always the hardest part of software engineering, right?
I'll take that as a note to myself to update the documentation. Yep.
Right. Well, this is truly practical AI. So solving problems on the fly.
Hey, guess what? Brain Science is officially launched. Episode number 1 is on the feed right now, so head to changelog.com/brainscience to listen, to subscribe, and to join us on this journey of exploring the human mind. Once again, changelog.com/brainscience, or search for Brain Science in your favorite podcast app.
It looks like RedisAI is currently supporting PyTorch via LibTorch and TensorFlow via libTensorFlow, and also Onyx Runtime as backends. That's pretty awesome. How big of a role did Onyx play in your strategy, around modules and stuff? And can you describe it a bit to our users on even defining what Onyx is, actually?
Onyx Runtime is effectively the Microsoft backend, or the Microsoft variant. The reason why we added it was because we wanted to combine, we used to have Redis ML, right? So that was purely machine learning. And Onyx Runtime effectively allows you to also serve machine learning models, compared to PyTorch, for example, and TensorFlow.
So Onyx provides like a intermediate between a bunch of different frameworks, right?
Yes, it does.
Yeah, so am I right that you have like PyTorch and TensorFlow, sort of the native libraries, and then you kind of use Onyx for like everything else? Is that the kind of thought process, or?
That is a thought process, exactly, right? So we can export, we can use Onyx Runtime as an intermediate format. Effectively, we're using it in certain ways where we, for example, want to fetch some models from Spark. We can effectively then transform them in Onyx Runtime and then upload them into our backend. It's interesting to talk about these different backends because the model command on how you execute, or you effectively want to do your regression classification, agnostic from the backend that it's running for. So when you would set your model, when you say, hey RedisAI, I want you to host or serve my model, you would have to add some backend specific stuff. But once you want to run it, it doesn't know anymore which backend is effectively underneath. Obviously, RedisAI knows, but it's your client doesn't need to specify, hey, run me this with TensorFlow. So which makes that your client library, or your application developers that want to run, want to work with your model, or your as a data science trained model, they get a fixed API. And as a data scientist, you decide, over time, we think that our model in PyTorch is better than our model in TensorFlow. You can just update that by setting a new model with the same key inside Redis, effectively RedisAI, and all your client libraries will still keep on working.
Yeah, that's pretty cool. So I'm just trying to think. What you just said makes sense. I'm trying to connect it to like, practically, if like, let's say we take the example that I had before. So I've got like my vectorizer that I've I've created, let's say in scikit-learn, which I can convert to Onyx format. And I create a bunch of knowledge base article entries in Redis. What would be kind of the steps I would go through to actually get something running to where I could take all of those articles in and then vectorize them with my scikit-learn TF-IDF vectorizer and then save them back into Redis? What would be required for me to do? Would that be like writing some Python? Would that be like some sort of custom client? What all would be involved there?
So it's a good question. We do have a couple of client libraries. So there's a Python client for RedisAI. There's also a conversion toolkit that we kind of like created to help you convert in between these different models if that would be necessary. So via Onyx runtime. So which we can probably share later on or at the end of the podcast. So from within your Python code, you could effectively just publish your model inside RedisAI. You could push it directly. You could connect. Hey, here's my database. I want to push this model. Obviously, there might be other ways that you still want to do this, right? You might have some intermediate, some versioning of or exporting your model as a binary, so you could actually version it, and then you could ship it to DevOps, so they can effectively. Well, there is a component missing there to make this easily, right? To version your model and to effectively say, hey, this is now the new release we want to publish inside RedisAI. You could do it directly. You could say, hey, here's my client, and I directly push it to Redis. And then afterwards, if you want to do that, you want to run that model, you can once again use the same client. But however, that client can also be wrapped in any other application that wants to consume that model.
So I'm just kind of curious. We've kind of talked a little bit about some of these use cases. Are there any before we move on? Are there any other really typical use cases that you're seeing RedisAI being used for that we haven't already covered?
One of the things where we think is transaction classification. And the reason why we think that's a very good fit is because it's a high volume, high number of requests you want to do, and you only have limited time to do so. So you don't want to waste time to find all your metadata or to fetch all your metadata from user profiles that live potentially in different data sources. So I think transaction classification, some fraud detection, are the ones we think that will really benefit from that data locality and the scale we can offer with Redis.
I have a kind of, I guess, more philosophical question to ask. So I would say that like probably, at least from my experience, like there's probably a lot of like maybe even most like software engineers these days, like they've at least heard of Redis, or they may even be familiar or worked with it. But maybe like data scientists and AI people are like less familiar with Redis. So do you envision, I guess my question is like, there's a lot of people already using Redis for certain things, like you've already mentioned like message brokers and other things where they have data already flowing through Redis. Do you think that it's likely that kind of the software engineers already using Redis will kind of be able to kind of bolt on AI sort of functionality into those existing applications? Like maybe they want to introduce like fraud detection in terms of the traffic going across their network or something like that. Or are you kind of hoping to kind of position RedisAI more as like a general purpose sort of model serving framework where AI or data science people, when they go out looking for the best way to serve their model, kind of RedisAI is up there with like, TensorFlow serving or whatever else it is. Do you think that there's like I don't know, maybe it's unclear right now in terms of which direction it would go, but I was curious to hear your thoughts.
I think we would love it to be both, effectively, obviously. But so I do think that we still have to build some tooling around this, right? So to make the full-fledged model serving engine, to make it very practical. By the way, one thing I also want to mention here is that we're effectively not all the development of RedisAI is done by Redis Labs. It's also done by TensorWorks, so we're partnering with them. And TensorWorks is a company that is building kind of like several tools for AI purposes. So one of the things they're building is might be interesting for you guys to also look into is a versioning system for data. So you could effectively well, like Git, you could effectively branch and make PRs on top of your data.
Yeah.
The data you want to serve to. Well, it's called Hangar, and I'll also recommend you to look into it. But over time, effectively, we think we will get a very nice toolkit. RedisAI will be one of those pieces into it, right? So I think, combined with TensorWork, we would like to make the story where we can say, hey, we've got a complete solution towards you for serving your model. On the other hand of the spectrum is in that case, well, I don't know who the personas would be. For sure, it's a data scientist, but also, for example, DevOps people that want to have a good solution for serving those models. On the other hand, there is potentially also data engineers and our software engineers who do already have Redis as a tool in their toolbox, and with these modules, they can make all these beautiful new applications. So ways you could use RedisAI combining them, for example, with other modules. So if you have a search application and you want to say, well, hey, I have these top 100 results here, or I have 100 or 200 results. Why don't I run them again through some model to update or to fine tune the scoring in between those results? It might have a big impact on the user experience. So we hope in that way. This is just an example, right? But we hope in that way that we will enable that many new or interesting applications will appear.
So we're kind of already talking about, what you're thinking of going forward. So I'll just go ahead and, ask, what does your development roadmap look like? Kind of what future directions are you interested in taking? And I know that we've, obviously there are features that you're going to have in mind, but, it sounds like, we've really covered a lot of tooling. Are there any kind of higher level applications that might sit on top of Redis as part of that development roadmap?
Yes, we should definitely look into that, and we're open for lots of tips and recommendations on top of that. For that, we do have a kind of like a roadmap for RedisAI itself. We do have a couple of features that we want to add. So we would like this Redis Gears module to talk natively to RedisAI. That might be interesting to, you have the script, but you could also fetch data more easily, or maybe even connect to other data sources outside Redis. There is also some batching that we want to have, so that we can effectively, you can run several models in one go. So there will be also one other thing that we want to add is some tooling to get some performance statistics about how well your model is running or behaving. So what is the average time, and the beauty that we hope to achieve is that, there's already an entire ecosystem around Redis. So some guy somehow will have written, for example, some Prometheus connector, right?
Sure.
So if you can connect that up, then you immediately get some Grafana dashboard out of the box that could show how well your model is behaving. That is one thing. I'm sure we will have many more. There's some versioning potentially of models that we also would like to do. So we can have, we can keep track of several models or versions. So you can have, you can switch in between them, or do A/B testing in between them. That could also be an interesting thing to look into in the future.
Awesome. So as we kind of wrap up here, I was wondering if you could just share kind of maybe where, I think on one front, like where people that are interested in experimenting with RedisAI, where they should go to kind of get up and running, I guess. And then second, I'm sure that there's a lot of work to do. There's a lot of tooling that's needed, integrations, all of that stuff. So maybe there's people out there that have used Redis, or not, but that would be willing to contribute. So where should they go to kind of get plugged in? So on one front, people that want to be potentially users, and then maybe people that want to contribute as well. What's the best way for those groups to get involved and find out more?
So if you just want to get started with it, there's a Docker container. Effectively, all the info is on redisai.io. To quick start, there's a Docker container. You can just pull it. It comes preloaded with all the backends. So it comes with TensorFlow, PyTorch, and NOx runtime backend. And you can just get started with that. If you would like to contribute, there is a Google Groups where you can effectively, all RedisAI, right? So if you would search for the Google group, all RedisAI, where you can effectively reach out to all the developers that are working on RedisAI and contribute there, right? It's a GitHub project. You feel free to open issues. We would love that, right? All the feedback you guys can give us would be highly appreciated. I think we react quite quickly to those two, right? We would love to help or to make RedisAI a success.
Awesome. Yeah, I think that's great. And of course, we'll post all of those links that were just mentioned on our show notes. And of course, if you're having trouble finding things or want to kind of follow up with questions, find us on our Slack team at changelog.com/community or our LinkedIn page. We're happy to make the connections for you, forward on links. But I thoroughly enjoyed today's conversation. I was able to like nerd out a bit and think about my own problems a little bit. So I appreciate you being patient with me, Pieter, and sharing so much great information.
You're welcome. No, I really enjoyed it too. So it was an honor for me to be here. So thank you for asking me.
All right, thank you for tuning into this episode of Practical AI. If you enjoyed the show, do us a favor, go on iTunes, give us a rating, go in your podcast app and favorite it. If you are on Twitter or a social network, share a link with a friend. Whatever you got to do, share the show with a friend if you enjoyed it. And bandwidth for changelog is provided by Fastly. Learn more at fastly.com. And we catch our errors before our users do here at Changelog because of Rollbar. Check them out at rollbar.com/changelog. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. Check them out. Support this show. This episode is hosted by Daniel Whitenack and Chris Benson. The music is by Breakmaster Cylinder. And you can find more shows just like this at changelog.com. When you go there, pop in your email address, get our weekly email keeping you up to date with the news and podcasts for developers in your inbox every single week. Thanks for tuning in. We'll see you next week.